Another concept is crossover. What is crossover? Let's see. I have a satellite, altimetry satellite, moving along the orbit, and this is the Earth surface, and this satellite has a ground track like this, and it takes time that this, let me see, this is ascending track. Ascending track. It means that the satellite goes upward from the equator, ascending track. And after a while, when the satellite goes downward from the respect to the same satellite, then we'll get some ground tracks like this. And as we see, in over some areas, some points, the aligned track and ascending track and descending track collides. But actually, so we know that the altimeter data are measured point by point, like that, point by point. And also aligned track, the ascending track as well. So they do not actually coincide over this area. Then we need to compute the crossover. We will discuss this later. This type of crossover, that I have one satellite, and the ascending track and descending track collide each other, is called single satellite track. Single satellite, it means only one satellite. Now consider another type of satellite. So I write the blue satellite is moving, and it has a track. There's a ground track here. And now I have another satellite, and this has another track. Could be ascending, could be descending. They will collide each other like that. In this case, we say that this is the dual satellite track. Dual satellite track. So it means that the tracks between two satellites. So we may have different satellites in multi-altimeter satellite, and we can consider all of them. But for the crossover points, we consider 2 by 2, or a satellite with itself, or one satellite with another satellite. So how do we do that? Let us start with the single satellite. Single satellite crossover, CO, crossover. I have one track, ascending track, with these points, and I have a descending track with these points. This is descending and this is ascending, okay? But it does not occur that we have any point here. So simply, we can write an equation for line for this one, passing through these 2 points, and another equation of line passing through these points. Then we can, from those equations of line, we can compute this crossover point. This was single track. The principle for dual is the same. Satellite, CO, crossover. You have some points in that way for one satellite, but the other one from another satellite. So what is the difference then? For a single satellite, you use the same sensor. You will use the same transmitter and the same. But for dual satellites, you use different sensors. What is the point? It means that when I come to this crossover point, if I write the equation for the crossover point, what is the equation? For example, for SSH1, SSH ascending, I will say altimetry measurement in the ascending mode minus, no, that's right. Height in the ascending mode minus altimetry measurement in ascending mode plus corrections in ascending mode. So now I have SSH for descending node at the height for descending node and A for descending node plus correction for descending. These corrections, we can compute them. We have no problem with that. This elevation is also computable. There's no problem with that. And these are also computable. So that's no problem. What we expect is that SSHR minus SSHB should be 0. But do not forget that we have removed the effect of tides, effect of variations, wind, and everything. It should be 0. So if it is so, we get the same height and so on. And if we have some errors, for example, in HA, and these errors for this one, and errors, for example, for the sensor here for A, for delta, for sensor for this one, and this one, the sensor. Since we have used the same sensor, this error, let me write it, HA. Let's assume that the error of orbit is constant. I'm just emphasizing on the error of the measurement, and the sensor error is here, and the other side, HD, the descending road, and I'm using the same sensor. Therefore, the delta, this error of the sensor is the same. And as you observe, the error of the data that which is collected, if any systematic error exists, then it can be removed simply with this crossover, writing crossover. But this is not the same for dual satellite. The dual satellite, they will have another, for example, if I rewrite it again. For dual satellite, I will write H, for example, satellite 1, A for the satellite 1, then I will have the error of the sensor. Then H2 minus A2 minus delta 2. So we cannot eliminate this error because the sensor for measuring alpha in both satellites are different, and the errors are not the same. Therefore, the difference does not eliminate. Maybe it reduce some common sources of errors, but not completely. This way is the one way to calibrate one satellite with respect to another satellite. Calibration. Probably you have heard about altimetry calibrations over crossover area. So, for example, SSH measured by the first satellite should be equal to SSH we measured with the second satellite. Theoretically, it should be so, but it is not so. Then if I want to see how much one satellite is different from the other one, then I can consider this difference as a calibration factor, SSH2 or 1. So as a calibration factor, let me call it quick. But then it needs to be studied, because when you compute these crossovers, and these crossovers are repeated in time as well. So it's not only that this crossover is also only one point. They are repeated. But which time? You should look at the time for time synchronization and removing the effect of and you have to consider that based on that, say that SSH should be the same at this point. You can see, for example, if you consider JSON 3 satellite as a reference, then you will compute how much different is, for example, Sentinel-3 or Sentinel-6 is from JSON-3. Then you can calibrate it. You can correct the measurement of the, for example, Sentinel or Sentinel-6 in such a way that the SSH you get will be the same with the one you get for JSON. So that's the way that you can calibrate satellite altimetry data in comparing to each other. That's one way. Of course, you can calibrate satellite altimetry data with comparing with tide gauge, but its principle is similar. But instead of one satellite, you have tide gauge. Of course, the errors will be different. And again, consider that satellite altimetry data is not good quality over shallow water.